Hi everyone, I hope you're okay. This is the ninth video, guys, which simply means I've answered 9 questions based on this question paper. Uh, the question paper, guys, is the May-June 2024 IEP examination. If this is the first video you come across, just know that there are 8 videos before this. Just download the paper, answer the question paper with me, and then if you have misunderstandings there and there, please write on the comment section. I will try by all means to rectify the misunderstandings. Okay, we are given f of x and g of x. The first thing we are asked to determine the general solution. Okay, we must just equate the two. I have sine 3x is equal to tan 3 over 2x. Tan 3 over 2x. Okay, the first thing I need to do here, guys, I have sine 3x and I have tan 3 over 2 on the other side. I know that 2 multiplied by 3 over 2 will give me 3. So this thing simply means I can change this guy and express it as a double angle. How so? I can write it as sine of 2 multiplied by 3 over 2x, like this. And then I'll change everything into sine and cos on the other side. It's sine 3 over 2x all over cos 3 over 2x. Are you together? And then on the left hand side I can express the double angle. It's 2 sine 3 over 2x, and then I have cos 3 over 2x. This thing is equal to sine 3 over 2x all over cos 3 over 2x. I'm trying to solve an equation here and I have fractions. The first thing I need to do is to remove the fractions, right? By multiplying everything by the LCD. But please remember that, guys, there must be a restriction. Whenever I'm solving an equation and I have a denominator, please note that there must be a restriction. Cos 3 over 2x cannot be equal to 0, because when it's equal to 0, it will make the right hand side to be undefined, and the entire equation will be undefined as well. Okay, so let's continue. Must multiply everything by the LCD, right? So I'll have 2 sine 3 over 2x multiplied by cos squared 3 over 2x is equal to sine 3 over 2x, right? Now I don't have fractions, but what I can do is to bring everything to be in standard form. So I'll simply have 2 sine 3 over 2x and cos squared 3 over 2x minus sine 3 over 2x is equal to 0. There's a common factor in here, guys. Now my common factor is just sine 3 over 2x. Whenever I remove sine 3 over 2x, I will be left with 2 cos squared 3 over 2x minus 1 is equal to 0. Are you together? But 2 cos squared of an angle minus 1 is an expression of an expanded version of a double angle identity. So this will give me sine 3 over 2x multiplied by this is cos 2 multiplied by 3 over 2x is equal to 0. Are you together? So I'll simply have sine 3 over 2x multiplied by cos 3x is equal to 0. And then now I'm supposed to solve for x. I have two things multiplied and the answer is 0. I can simply say the first thing is 0, or the second one is 0. Okay, I'll treat these two things differently. Firstly, I need to find the reference angle. So when I say reference angle of sine inverse 0, I'll get 0 degrees. Are you together? And I know that 0 is just a number which is positive, so I must express my reference angle where sine is positive. I know sine is positive in the first quadrant, so I'll simply have 3 over 2x is equal to 0 plus k 360, where k is an integer. Then if I divide everything by 3 over 2, I'll have x, I'll have 0 there. When I say 360 divided by 3 over 2, I'll get 240 plus k 240, where k is an element of integers. Are you together? And then the other solution, let me write it in black. Remember that I have to express 0 where sine is positive, right? So I know that sine is also positive on the second quadrant. In the second quadrant, yeah? And in the second quadrant, I express angles as 180 minus. So 180 minus 0 is just 180. Are you together? Plus k 360, where k is an integer. So I must divide everything by 3 over 2, so that x will be equal to 120 plus k 240, where k is an integer. So these are my general solutions. Let me highlight them. The general solutions, here are they. And then on the other side, my reference angle is cos inverse of 0. Cos inverse of 0 will give me 90. 0 is a positive number, remember that, right? So I must express 90 where cos is positive. Excuse me. Cos is positive on the first quadrant and the fourth quadrant, right? So I'll say 3x is equal to 90 plus k 360, where k is an element of integers. Whenever I divide everything by 3, I'll get x to be equal to 30 plus k 120, where k is an element of integers. This is the other set of the general solution. And then I must also express the 90 degrees on the fourth quadrant, right? And angles in the fourth quadrant, I express them as 360 minus. So I'll say 3x. Let me use green. 3x is equal to 360 minus 90 will give me 270 plus k 360, right? So I know that whenever I divide 270 by 3, I'll simply get 90. I'll simply get 90 degrees plus k 120. So these are my general solutions. This one, that one, that one, and that one. Then I'll get my full 8 marks. Then secondly, I'm supposed to sketch the graph of f of x and g of x on the same set of axes, provided that the domain of x is from 0 to 120. Show all the intercepts with the axes, point of intersection between the graphs and the turning points. Okay, I have the graph. Remember that, guys, I was told that f of x is sine 3 theta. Let me underline here. F of x is sine 3x, and then g of x is equal to tan 3 over 2x, right? Okay, let's draw these graphs. For me to draw the graph, guys, I only need, firstly, let's start with the graph of sine. Yeah? Do you have space there underneath? We do have space. F of x is equal to sine 3x, right? There are steps that I use to draw the graph. The first thing I need to find is the period of my graph. Period is always 360 all over the coefficient of x, which is 3. So my period is 120. The period, guys, simply means that the complete wave of my graph will start from 0 and finish at 120. All right, together. And then the second thing I need to find is the interval. Interval is always period all over 4. Period is 120 degrees all over 4. I will get 30 degrees. All right, together. So this thing simply means that from the starting point, after every 30 degrees, I'll either get the x value turning point or the x-intercept of my graph. The interval tells me about the x value at the turning point or the x-intercept of my graph, right? So after finding the interval, all I need to do is to use my unit circle. This is called a unit circle because the distance from the center to the circumference is 1. Basically, the radius is 1, right? So if the radius is 1, it simply means that the coordinates at this point, I have 1 and 0. I have 0 and 1 here, minus 1 and 0, and then 0, 0 and minus 1. Okay, remember that, guys, we have the graph of sine. Since we have the graph of sine, that means we are considering the x values of the y values rather of the unit circle, right? But please check this. There's nothing added next to the angle here, which simply means that our starting point is at the origin. All right, together. Our starting point is when x is equal to 0. So x is equal to 0 degrees. And then to find the other points which are there, all I need to do is to just keep on adding my interval. So 0 plus the interval, I'll simply get 30 degrees. 30 plus the interval, I'll get 60. 60 plus the interval, I'll get 90, plus the interval is just 120 over there. Yeah? So this thing is simple now. If this is 1, 2, negative 1, and then we have negative 2 over there. What I need to do here, guys, is to just plot by using these things. When I'm at 0 degrees, what is the value of y? The value of y is 0. Are you together? When I'm at 30 degrees, the value of y is 1. When I'm at 60 degrees, the value of y is 0. When I'm at 90 degrees, the value of y is minus 1. When I'm at 120, the value of y is 0. So my graph will go like this. That's how my graph will look. Are you together? And then now let's go and draw the graph. Katane. If drawing a graph, guys, confuses you, please note that I have a video there in the trigonometry playlist whereby I teach how to draw graphs. You can go and watch it there. Don't worry, guys, the graphs are not difficult, man. Whether you're in paper 1 or paper 2, you must take everything there, as long as it is regards to graphs. Okay, for tan, I was told that g of x is equal to tan 3 over 2x, right? First thing I need to do is to find the period. The period of my graph is always 360, 180 all over the coefficient of x. Are we together? So 180 over this guy, 180 all over 1.5, I get 120 as my period. Are we together? Which simply means the complete cycle of my graph will finish at 120 degrees. Secondly, find the interval. For tan interval, we say period all over 2, which is just 120 degrees all over 2, right? And then for tan we use a thingy, we use a Cartesian plane, not unit circle. Ne? For tan it's just simple. I don't care what values are here. All I know is that those values will be my asymptotes. Are we together? And there's nothing added next to 0, so that means my starting point is at x is equal to 0. Are we together? So all I need to do is you just keep on adding the interval. 0 plus the interval, my interval is 60, right? 120 over 2 is 60. Let me write it there. My interval is 60, so I'll have 60 there, and then 60 plus 60, I'll have 120. So I don't need to go further because I was restricted to stop at 120 degrees. Are we together? So please note that if the coefficient of tan is positive, that means the first thing we will do is to move from the x-intercept to the asymptote going upwards. If I know my direction here, it will be easy for me to find the direction in the other quadrants. They'll just keep on alternating. If I started with up, that means I'll have down here, up there, and down there. Are we together? But I don't need these two because my graph has been restricted to these two quadrants. Okay, let's draw. The asymptote is at 60 degrees, right? The asymptote is at 60 degrees. From 0 to the asymptote of 60 degrees, we are going upwards. But remember that initially we did calculate the x-intercept, right? And one of them was 30 degrees, and the other was 120 and 90. So my graph will look like this. Will cut. It has to cut here at 120 degrees and go upwards like that. Ne? From 0 to 60, it must go up, and then from 120 to 60, we are going downwards. The two graphs intersect at 120 and 90 degrees, so it must go like that. Remember that we calculated the general solution for the equations together. So I know that at 120, the two graphs will intersect. At 30, they will intersect. At 90, they will intersect as well. Together. And at 0 degrees, they will intersect as they just did there. Together. So that's how you'd have tackled the question. Second question. Or not second question rather, but the last one. They want us to determine the values of x for which the graph of f is above the graph of g. Okay, the graph of f is above the graph of g. Where do we see that? That place is only here, between 0 and 30 degrees. Where else do we see that? Yeah, that's the only place. When x is between 0 degrees and 30 degrees. That's how guys would have tackled this question, from general solution to drawing the graph and interpreting the graph. I really hope guys that you are okay with this thing. It doesn't give you problems. Just stay tuned guys and wait for more videos, and don't forget to subscribe.